Alright, I think we're live. I'm just going to share the link on Twitter and then we'll get started. Alright, so the plan for today is I'm doing some work on getting the big space station that I've been working on into my game. Just want to make sure that the video didn't stall up. Okay. Yeah, so I'm doing some work on getting the big space station that I've been modeling into my game. So the way this whole project works is that I have kind of I have code that generates all my 3D models, not procedurally but programmatically. So I'm kind of clearly defining the little details and shapes of things and everything. But I have a couple different versions of things. I have a very high detail version that's kind of more for fancy 3D models, for detailed renders and stuff, and then I have this kind of cool low poly retro version that's going into this kind of retro stylized game that I'm making. So last time I streamed, we were working on a comm array that goes on top of this big space station. Now I'm working on some components that will make the comm array a low poly version of the comm array for the game version of the space station. So I'm just gonna get some music started here. I think the music was a little quiet last time, so hopefully it'll be a little bit louder. And I'm going to talk a little bit about what I'm doing here. So yeah, the actually, just let me make sure that I'm not sure that the music is working. Let's see here. That's unfortunate. Let me experiment with this a little bit. So it's funny. I thought I had this set up last time so it would capture. Music. Okay, macOS screen capture. Yeah, why isn't this working? Properties. Huh. I actually stop streaming and then reconnect and see if that fixes it. I'm back. I'm back. I've got the audio working. And we're working on this truss. So, so we have the 3D version of the truss, and I'll go back. I had forgot to restart streaming to show what we're working on here. But I've been working on the space station, and I'm replacing the 3D version of this truss with sort of a 2D kind of like flat plane with cutout holes in it version. And I have this unit test set up that will generate the 3D version and then the corresponding 2D version for comparison, so we can kind of make sure that dimensions are the same, things like that. We'll look at them side by side in a little bit more detail. But the way I'm setting this up is there's going to be this rectangular outline, and then inside of it we'll have these triangular points. And I just realized I added the wrong offset here, but these triangles that we're going to triangulate around. And then, but we need to add extra points around the outside so that there's enough places for the triangulation to connect. And this is not going to be height mod, it's going to be height. Okay, so now if we plot everything together, this should look like something that if we triangulate, we'll get a reasonable result. Yeah. Okay, and these are offset, so I need to kind of swap. Well, yeah, I need to swap these because I want to make sure we don't have any issues triangulate. I want this point to set here so triangles can run off of it. I hope the triangulation actually works. If it doesn't work, I'll have to come up with a different approach or just sort of manually do the triangulation, which I don't want to think about doing right now, but it probably would work. So we actually have to swap points bottom and points top here. So that's a little awkward by name, but it's not a problem. Oops. Gotta swap these here too. See how that looks. Yeah. So my thinking is that this should give enough kind of points in proximity that this can be triangulated and have these cutouts be holes. So let's see how that works. And I'm just gonna get rid of all of this. This is kind of copied over from the 3D high detail version. Okay, so let's try to triangulate it. So we're going to triangulate with the boundary and then holes. And let's take a look at this. And I think actually I want the 3D version. Do I want the 3D version? I think the 2D version is fine. Because I don't care about getting the original ordering back. I don't care about that. So We can do this, and then gotta add our Z coordinate in here. Whoops, bad polygon. I was afraid that was gonna happen. And I wonder why we're getting that error, because I don't see anything about this that looks bad. Is there actually something bad in here, or is it just that the triangulation can't deal with this? So I'm going to try a couple things. We'll kind of debug this together. So first I'm going to take out the ending. Nope, that still gives a bad polygon. Actually, let me just, I'm also going to try one thing here. We'll try the 3D version, see if that works. I don't think it will. That also gives a bad polygon. So what, I'm gonna try adding some more points, see if that helps. I could write code that would sort of do the triangulation myself, since I know what pattern this is going to be in, but I don't really want to do that because I'd like to be able to modify these cutout triangles in different ways to get different shapes. So I don't really want to do that. Okay, so let's try this. Somewhere I've got an interleave function. I think rather than interleaving these, I can just make a new one. So we'll run here, but segments times 2. And we'll do plus width divided by 2. And so we'll basically substitute that in here. Still getting bad polygon. That's unfortunate. I really thought that this would work. And like, just to be clear here, so the exception is when we're doing the trimesh dot creation dot triangulate. That's too bad, because I think that means so the next thing that I'm going to try is just see, will it work with just a single triangle? So if I just do like one of them, whoops. Oh yeah. Let's put this in a parentheses so we can comment different parts of it out. So let's take these out. So we should just have one triangle here in the middle. Oh, man, polygon. Oh, maybe there's something else going on here. Oh yeah, that's the problem. So we've got a repeated vertex here at the bottom. And let me just makes me nervous that this isn't showing either. Oh, that was out of the range. That's why it wasn't showing. So there's only like 5 in there. So yeah, let's just stick with one first. But the problem is this guy. And this is just, yeah, this is totally out of whack. So my logic there is not right. Let's fix that. So we go back here. Yeah. So I'm maybe have revs switched around or something here from what I thought. I'm surprised that it still drew like I thought, but I suppose that could be happening if things are doubling back on themselves. We want 0, 1, and then Yeah, okay, I got the revs backwards. That's what happened. So this has to be mu.rev. And let me just disable this guy because we don't need to look at him right now. Yeah, and then we want to get rid of these here. Okay, let's see if that does it. One, two, three, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, that looks much better. Now, let's just stick with one side and see, or with one hole and see if we triangulate. Yeah, see, there we go. Okay, now let's add the rest of them back in. We'll save the ones on the ends for last. Yep, there we go. Haha, good. Perfect. Okay, now basically we just have to put. Katie's saying hi. We just have to put these together into our truss. So we want one for each side, and so let's first rotate the side. Okay, and then we want to translate this up by the apothem, which is the length between the middle and the center and the middle of the side of a polygon, and then spin by repeating it around however many times for however many sides we have, and then that should do it. Then we just have to concatenate, process, stuff like that. So translate side them, and then we want to concat side dot spin, and I think actually I should check spin. Yes, so most of the time the way I set my project up, the y-axis is kind of like the long axis of a ship or a truss or a piece like that. So usually we're spinning things around the y-axis. So and we want to do yeah, I think chords. And then, oops. So we'll take a look at the side and the final result. We've got to process it once we're done. Whoops. Offset, I think, is just going to be 0 here. I might have to check the other truss code for what the offset should be, because I want them to kind of match up. There's all kinds of different conventions that you can take when you're talking about how you want to make polygons. Yeah. That is exactly what I wanted it to look like. But depending on what we want for the offset, I think we're going to want a slightly different offset. And let me get rid of some of these. See what the spin. Oh yeah. So this is adding the offset in so that things will be offset correctly. I think that offset will still work here. Yeah, so you can see we have one of the chords of the truss going through, intersecting the x-axis. And okay, not quite. It looks like yeah, we have it intersecting the z-axis instead. So I think that's due to how I've done this, but I think we can get the same result by subtracting maybe. Nope, not quite. Okay, so we'll do this a little bit differently. So here we've got to rotate like this, and then we also have to rotate around x, and then we've got to translate like this, and I think that will give us what we want. Whoops. Whoops. Oh, yeah, not around x, around y. Yeah, see, there we go. And let's see, do I have, yeah, it looks like I have the faces facing the right direction. So I have the faces facing out. Now, let's just compare a little bit more closely, because I want to, I'd like, ideally, you know, everything kind of matches up between these two. So let's see if that's the case. Yeah, and see. Yeah. Yeah, perfect. Now we can do a little bit better, right? So this isn't eliminating repeat faces. So let's do that. So if we view it and then process, and let's just process no validate so it doesn't try to figure out which direction to flip the faces. So we got 378 faces or vertices and 506. Here we got 162, 234, and then 156, 234. So that drops down the number of vertices by quite a bit. Okay, so one last thing here is that there's a Boolean for ends. So ends is whether or not to put little sort of end caps on. I'm not gonna bother right now implementing this fully the way I want to implement it, but I do want to add one more little detail, which is just having like a perpendicular end piece that goes on. So that is going to be um, it will be a polygon that's just inset by the I believe by the web radius. Let's see here. And yeah, web radius. Okay, so let's create that quick. Okay. Radius, and this is going to be web radius times 2, actually. Because we want the full diameter of it. So now we have to add a y dimension. And we'll just make the two ends like this. So divide by 2 and minus length divided by 2. We're gonna have to flip one around here, but I don't want to think about that too hard. Oh. Yeah, this is gonna work. Yeah, this actually, yeah, we wanna attach here. Tried to be too clever. And here we can just add. Just for clarity. Then I'll do the rotating and flipping and stuff before. Whoops. Some of my primitives don't have the best interfaces. Oh, yeah, that's not the function I want. Let's see, where is it? Yeah, that's what I want. Set subs. That's funny. Okay. Gotta figure out what's going on here. Yeah, that looks like what I want. Looks like exactly like what I want. So what's going on here? Oh, that's weird. Yeah, that's strange. Oh, that's weird. I guess it was that was appending tuples. Yikes. Yeah. Okay. Yep, okay, so now I also just have to flip this one 180 degrees around so the faces are pointing the right direction. So let's do that. Actually, it's the positive one that needs to be flipped around. So let's just use rotate. Yeah. Oops. Been using Max for like a few months and I still am not quite used to some of the keyboard shortcuts. Oh, wrong way. See, red, green, blue. Yeah, that's weird. Is that not supposed to be? Oh, yeah. I need to actually mirror it. Actually, I can just flip the faces. Yeah, I don't want to rotate it. flip faces, and yeah. Whoops. Yeah. Okay, so now if we yeah. So there, now we have a nice. Now in the game, I'll set this so that both, you know, double-sided rendering is enabled, and it'll look nice. So, all right, so that's done. So now we can go back and go ahead and use this in our space station. I'm gonna just check Twitter quick. Okay, so let's get these into the game. I think I also, or not into the game, into the model, and I'm also gonna probably try to do a modified low poly version of the satellite dish if I don't already. That will make that also just a single layer, not have an actual volume to it. So we'll see how that goes too. So let's just look at what we have right now. We have the station. Each of our comm array antennas has like 6,000 triangles, which is a lot. It should be considerably less with this. And honestly, even if it's not less, it will look more appropriate, right? It will look more like what you would expect a low poly kind of retro styled game to look like. I see Timo Burnham is in the chat. Howdy. Almost to the point where I'm gonna be replacing these. And see, I've already, for this low poly configuration, I've already reduced the subdivisions on these poles by a lot. So there's these are already, you know, a lot less detail than you would want for rendering. So let's take a look here. So basically, here's my logic in my tower function. So basically, I want to say if LOD is less than 0, we're going to do this. Otherwise, we're going to use our new low detail truss. And actually, I'm going to move this logic out. So we'll just do tower equals cat tower width. Those right there. Actually, I'm just going to, just before I get too far ahead of myself, I'm going to test and make sure that that was correct. Set parent. Yeah, so Timo, this is for this is a space combat game. I'll run a little bit of the game here in just a second, so you can kind of see what it will look like. But this is the working towards a sort of low poly retro styled version of the station. So for reference, here's what the high detail version looks like. So there's a lot more greebling and stuff on this version, more subdivisions. You can see a lot more panels and things, and there's going to be a lot more detail like in this part of the station yet that I haven't done yet. I've got windows and different things, a lot more subdivisions on the curved parts. These will be even more subdivisions when I'm done with it. Just, they don't need to be any more detailed now. But for the game, so I'll just launch the game quick so you can see what it looks like. I don't think I would have broken anything here. It's kind of a low poly style that kind of follows like the look of like DOS games like MechWarrior 2 and TIE Fighter is another big influence. Maybe some of the early Wing Commander games before they started doing textures. And I want to be able to have this space station kind of stick with that style. So really don't want too much greebling or nothing should be too high of detail. And I think in that style, those towers or trusses wouldn't be constructed with actual like cylinders with faces and everything. They would be kind of done in this like with this flat style that I've implemented. So let's actually see what that looks like here. So if it's less than 0, we're going to build our tower this way. Nice. Yeah, I mean, I actually, when I was first starting to build out the game, I was looking a lot at YouTube videos of Star Citizen. I know people like to hate on Star Citizen, but it's got really cool, really well-developed space combat. Elite Dangerous is another one that I was kind of looking at, but yeah, part of what makes my game a little bit different than the actual retro games is that it's got more realistic physics in it, kind of like Star Citizen, where it's not like a plane in space. You actually have thrusters and momentum and things like that. So I think I probably took some inspiration from some of those games into how to do the gauges and different things that are shown. So it's cool that you said that. Okay. And we want to actually, before I forget, set this back to 0. Yeah, Timo says never really got the hate for Star Citizen. Seems like it's all coming from people who'd never actually played the game. Yeah, I mean, from what I understand, Star Citizen isn't maybe what some people hope it would be, but there's a lot there. And if you're kind of like a simulator type person, like the people who get big into like all these. I think there's the one called DCS, like the like serious realistic military flight sims, and like actual military people really like Star Citizen because it has really rich space combat, and like for those situations, a lot of the stuff that people give it a hard time for not having doesn't really matter because you can just go in and do cool space combat. So, if you're willing to invest the money, and I mean these guys are actually playing a ton, right? they're willing to invest the money to get new ships and stuff, and I don't know, seems like a cool thing to me. All right, let's see how this looks. Whoops, wrong command. Okay. Nice. Yeah, that's basically what I was hoping to see. And I think we were at like 6,000. Yeah, so this cuts the number of triangles down by about a third. You know, we could still get rid of more triangles. Oh, this is interesting. There's something a little wonky going on here at the ends. Let's debug that a little bit. Yeah, it's definitely a niche product, and people make fun of Star Citizen for like not delivering, but I mean, I think they're making the product that their customers want to pay for. So I don't fault them for it at all. Okay, so let's take a look at this. Is all working okay. I think it is just something going on with the ends here. Yeah. Let's see if we can figure out what's going on here. Oh, let's see here. I think I might know what's going on. Yeah, okay. So I think the problem here is actually how I'm making these towers, because I'm saying something like subdivisions. Let's see, segments. Yeah, int height divided by 2. I can't do this with this new method. Or I just have to round the height to an int. So let's first do that. So because this is kind of a custom function, I just want nice numbers here anyway. And let's see where I'm invoking this. Yeah, see these? Well, oh yeah. Height, no. Those are numbers that should round to integers. I think there's just something going on with that end adjustment that is kind of messing up that very end. Let's take a look once more here. So it's one of these ends. Oh, yeah. Okay. Interesting. There's some kind of integer or off by one issue going on here. Oh, I think I know. I think I know, because it's in... Yeah, we're dividing by 2, but then we're also assuming that we can divide... Yeah, yeah. So for all this to work, we actually want things that are not just integers, but even or numbers that can be divided by 4. And I think that's the problem. It's 150. Let's see, 150 divided by 4. Yeah, 150 divided by 4 is not an even number, or not a integer. So let's tweak this. Let's go to powers of 2 instead. Those are nice. Everybody likes powers of 2. It's a nice, let's see, 38. Powers of 2, or just like 152. Yeah. Let's see here. Just make a note of that here. Let's take a look now. Yeah. No, unfortunately, I think that throws off some other stuff. I don't know if these... Yeah, these probably weren't lining up like right before. Thanks, Timo. Okay. Let's see how long we've been going here. So we've been going for about an hour. I'm gonna do a little bit more work here to do some low adapt the dish function for low poly, and then we'll probably call it good. And maybe the antenna. So let's see here. Actually, that looks like the antennas are already just simple. I'll need to get rid of those. I think the antennas are already simple prisms without bubbles. Let's take a look. Yeah. Okay. Oh, and this we could really reduce the face count of too. Yeah. So probably at 8. Else. Equals 4. And we've got to give this guy a LOD argument. Set slot and subs 8. Yeah, we can get rid of that now. Yeah, see now we're more like 2,000 and 1,000 for each of these. That's a lot more reasonable. Okay. Yeah, let's take a look at these dishes next. So, see, they're currently, they have a little bit of a thickness to them. So there's basically like double the amount of triangles here that I really need. So let's fix that. So dish, and what I'm going to just do is I'm going to make thickness optional. So if thickness is none, we just do a single layer, not a manifold. So So if we actually have a thickness, then we're going to do this we're going to do this solid, this manifold solid. Otherwise, we're only going to use the upper ribs. And we're just going to do a where we start at 0. And I'm just going to make these vec3s too. So just upper, and we won't do an endpoint, so it'll end up being open mesh. And like in this case, let's just view it just to make sure that the faces are pointing the right direction they should be. Let's see here. So yeah. And again, when this is in the game, we'll set this to render double-sided, so it won't matter, but I just want to make sure that things are pointing the right way. Yep. Yeah, and see now we're getting down to much more reasonable vertex counts here. Actually have the same comma ray here on the bottom. So yeah. Okay, cool. Well, I think we're gonna call it good for now. We made some good progress on the low poly version of the station today. I'm pretty excited about this this simple truss logic, because that's going to actually be useful for a lot of things other than just you know, actual low poly trusses, but could be used for high detail greebling on different things, and just having that logic to make both those versions will be useful. So thanks to everybody who stopped by. If you catch the stream later, I'm going to try to be streaming my work on this project more. You can watch old live streams that I have of different programming and 3D modeling work that I'm doing with Python.